Students, as we are about to finish the Is Matter Around Us Pure, these are the videos which I am giving you are useful for you to understand the concepts with more examples and in a deeper format. So watch these videos and my explanation will be followed after all the digital content is completed, so that you can understand when I explain you in a very easy way. Must watch these videos and make sure that there is no disturbance back home when you see these videos. Thank you.
What do you say? Are they really pure? Let us find out. Welcome to the lesson on Is Matter Around Us Pure? At the end of the lesson, we will be able to define mixture, solution, suspension, and colloids. Demonstrate the separation of components of a mixture. Demonstrate the separation of two immiscible liquids. Explain sublimation process. Explain chromatography. Explain the procedure to separate mixture of two miscible liquids. Explain the separation of gases from air. Explain crystallization. Differentiate between elements and compounds.
Dad, is this milk really pure?
No, Abhay, this is not pure, as it contains water, fat and proteins. Since this milk contains more than one substance, it is a mixture. We see most of the matter around us in the form of mixture of 2 or 3 pure components.
Mixture? What is this, Dad?
Mixture consists of more than one substance mixed in any proportion. Mixtures such as salt in water and sugar in water has uniform composition throughout. Such mixtures are called homogeneous mixtures. Mixtures such as oil and water, salt and sulfur have non-uniform compositions throughout. Such mixtures are called heterogeneous mixtures.
I heard about solution in my class. What is that?
Solution is a homogeneous mixture of 2 or more substances. Solutions are solid like aloe, liquid like lemonade, or gaseous like air. A solution consists of solvent and solute. Solvent is a component present in larger amount, and solute is a component present in smaller amount in the solution. Depending upon the amount of solute present in a solution, it can be called a dilute, concentrated, or a saturated solution. When concentration of solute is comparatively low, then solution is dilute, and when concentration is high, solution is called concentrated. When no more solute can be dissolved in a solution at a given temperature, it is called as a saturated solution. For example, if we continue to dissolve salt in some water, then after certain stage, no more salt can be dissolved further. This is because the solution has become saturated. The concentration of solution is the amount of solute present in a given amount of solution.
And Dad, if solution is heterogeneous, then what is it called?
A heterogeneous mixture is called suspension, in which solute particles do not dissolve but remain suspended. Solute particles settle down when suspension is left undisturbed. Apart from solution and suspension, one more state called colloidal solution is there.
Colloidal solution? What is this, Dad?
In a colloid or a colloidal solution, the particles are uniformly spread throughout the solution. Due to relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with our naked eyes. But these particles can easily scatter a beam of visible light. The scattering of a beam of light is called the Tyndall effect. Tyndall effect can be observed when a beam of light enters a room through a small hole. This happens due to scattering of light by the particles of dust in the air.
Dad, can we separate the components of a mixture?
Yes, why not?
Dad, can we obtain colored component from this ink?
Yes, let us do an activity. First, fill half of the beaker with water. Now put a watch glass on the mouth of the beaker. Put a few drops of ink on the watch glass. Now start heating the beaker. You can observe that evaporation is taking place from the watch glass. Heat the beaker till you find only dye on the watch glass.
Oh, now I understand. That ink is a mixture of dye and water. How do dairy people separate cream from milk?
They simply use method of centrifugation.
Centrifugation? How is this method carried out?
Centrifugation is based on the principle that if a liquid is spun rapidly, the denser particles are forced to the bottom and lighter particles stay at the top. Centrifuging machine is used for this process. At home, by using a milk churner, centrifugation can be done. Do you know how we separate a mixture of two immiscible liquids?
No, Dad. Please tell me how to do it.
Okay, let's separate kerosene oil from water. To do this, we will use a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time, so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Close the stopcock of the separating funnel as the oil reaches the stopcock.
So, the principle is that immiscible liquids separate out in layers depending on their densities. Dad, I learnt about sublimation process. Where do we use them?
Sublimation is the process in which a substance changes from solid to gaseous state on heating. Sublimation process is used to separate mixture that contains sublimable volatile component and a non-sublimable impurity. Some examples of solids which sublime are ammonium chloride, camphor, naphthalene and anthracene. When mixture of ammonium chloride and salt is heated in a china dish, as shown, ammonium chloride evaporates and solidifies, and thus it gets separated from the mixture. Do you know, Abhay, what is the dye in black ink? Is it a single color?
No, I am not sure.
Let's obtain colored component from the ink. Take a thin strip of filter paper. Draw a line on it using a pencil, approximately 3 cm above the lower edge. Put a small drop of ink at the center of the line. Let it dry. Lower the filter paper into a beaker containing water so that the drop of ink on the paper is just above the water level as shown, and leave it undisturbed. As the water rises on the filter paper, it takes along with it the dye particles. A dye is a mixture of 2 or more colors. The colored component that is more soluble in water rises faster, and thus the colors get separated. This process of separation of components of a mixture is called chromatography. Chroma in Greek means color. Chromatography is used to separate colors in a dye, pigments from natural colors, and drugs from blood.
How can we separate a mixture of two miscible liquids?
Let us separate acetone and water mixture. We will take this mixture in a distillation flask. Heat the mixture slowly, keeping watch at the thermometer present in the flask. Since acetone has lower boiling point than water, it vaporizes and condenses in condenser and can be collected from the condenser outlet. Water is left behind in the distillation flask.
What if the difference in boiling points is less between the components?
For this, fractional distillation process is used. The apparatus is similar to that of for simple distillation, except that a fractioning column is fitted in between the distillation flask and the condenser. The beads in a fractionating column provide surface for the vapors to cool and condense. Air is a homogeneous mixture and can be separated into its components by fractional distillation. If we want oxygen gas from air, we have to separate out all other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get liquid air. This liquid air is allowed to warm up slowly in a fractional distillation column, where gases get separated at different heights, depending upon their boiling points. Nitrogen has the lowest boiling point and is separated first. At the middle of the distillation, argon is separated. Oxygen is separated at last as its boiling point is a little high. Do you see this salt? How do we get this from seawater?
Seawater is purified to get pure salt.
Yes, to remove the impurities of salt, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. Crystallization is also used to separate crystals of alum from impure samples. Let us do an experiment to obtain pure copper sulfate from an impure sample. We will take some impure sample of copper sulfate in a china dish and dissolve it in water. Now, filter the impurities. Evaporate water from the copper sulfate solution so as to get a saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will get the crystals of copper sulfate in the china dish. Color, hardness, rigidity, fluidity, density, melting point, and boiling point are the physical properties of any substance. Ice, water, and water vapor are different physical states of the same substance. The physical properties displayed by them are different, but they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and in flammability. Oil burns in air, but water extinguishes fire. Burning is a chemical change. Chemical change brings change in the chemical properties of matter, and we get a new substance.
You told me about mixtures, but what are the types of pure substance?
They are mainly classified as elements and compounds. According to Antoine Laurent Lavoisier, element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. For example, iron, gold, and silver are elements. They exist in their simplest form. Elements can be normally divided into metals, non-metals, and metalloids.
What are all these? Metals, non-metals, and metalloids.
Metals are shiny and they conduct heat and electricity. They are ductile and malleable and they have colors. Mercury is the only metal that is liquid at room temperature. Non-metals are poor conductors of heat and electricity. They are not lustrous, sonorous, and malleable. Examples of nonmetals are hydrogen, oxygen, and chlorine. Some elements have intermediate properties between those of metals and nonmetals. They are called metalloids. Examples are boron, silicon, and germanium.
What about compounds?
A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Water is a compound made of hydrogen and oxygen elements mixed in a fixed proportion. Similarly, salt is also a compound formed by chemical reaction of sodium and chlorine.
Then, Dad, what is the actual difference between mixture and compound? Are both the same?
Elements or compounds just mix together to form a mixture, and no new compound is formed, but elements react to form new compounds. A mixture has a variable composition. In a compound, the composition of each new substance is always fixed. A mixture shows the properties of the constituent substances. In compound, the new substance has totally different properties. The constituents of a mixture can be separated fairly, easily by physical methods, but the constituents in a compound can be separated only by chemical or electrochemical reactions. From the mixture of iron and sulfur, iron can be separated using a magnet, which is a physical method. But on heating the two elements strongly, we get a compound, which has totally different properties compared to the combining elements.
Visit ATEC Academy on www.atecedu.com or contact on 904 11 52777.
Go away! Smart Learning for All. Topic: Tyndall effect. Why does the sky appear blue? Don't know the answer? No worries. We shall find the solution. It is such a beautiful rainbow. Have you ever wondered how it is formed? A rainbow is formed when raindrops split sunlight into different colors. Sunlight, or white light, consists of many colors. However, only a few of them are visible to us. A band of these visible colors is called a visible spectrum. When we see a rainbow, our brain and eyes distinguish the visible spectrum into 7 main colors, namely red, orange, yellow, green, blue, indigo, and violet.
Aha! Ah!
Hey, did you notice that the size of the balls increased? Yes, you guessed right. The balls represent the different colors of a rainbow in increasing order of their wavelengths. Wavelength is the distance between consecutive crests or consecutive troughs in a wave. In a rainbow, as we move from violet to red, the wavelength of colors increases. Violet has the shortest wavelength, while red has the longest wavelength. Do you think that our eyes have a natural inclination towards blue as compared to violet? Yes, this is one of the reasons why our sky appears blue and not violet. To understand this, first, let us study about Tyndall effect. Tyndall effect is a phenomenon in which a beam of light scatters on striking the particles present in its path. This scattering of light is responsible for the blue color of the sky. We know that our atmosphere primarily consists of oxygen and nitrogen particles, along with dust, smoke, and other particles in comparatively smaller proportions. The size of these particles in the atmosphere is responsible for the color of scattered light. When the sunlight strikes particles of dust, smoke, etc., which are bigger than the wavelength of sunlight, all the colors of sunlight are equally scattered. As a result, the scattered light appears white. However, when the sunlight strikes particles of oxygen and nitrogen, which are smaller than the wavelength of sunlight, the colors of sunlight having shorter wavelengths, that is, blue and violet, are much more scattered than colors having longer wavelengths. But our eyes are much more sensitive to blue color as compared to violet. Hence, the sky appears blue to us.
Uh-oh!
For more educational videos, please visit www.smartlearningforall.com. Also, don't forget to subscribe to our YouTube channel.
Concentration of solution and suspension. Dear students, in laboratories, you must have noticed bottles of dilute or concentrated acids or dilute or concentrated bases. What do these words dilute and concentrated means? They specify the concentration of solution. A solution is said to be dilute if number of solute particles present in solution is less while solvent is present in larger quantity. A solution is said to be concentrated if large number of solute particles are present in solution. Also, each solution has a specific dissolving capacity of solute. Hence, when solution dissolves solute to its dissolving capacity, then it is known as saturated solution. Amount of solute present in saturated solution is called as its solubility. After solution is saturated, dissolution stops and solutes accumulates at bottom. If amount of solute present in solution is in less quantity than the dissolving capacity of solution, then it is known as unsaturated solution. So, concentration is defined as amount of solute present in given amount of solution or amount of solute dissolved in given mass or volume of solvent. Concentration can be expressed in following two methods. Mass by mass percentage of solution, which is equals to mass of solute upon mass of solution into 100, or mass by volume percentage of solution, which is equals to mass of solute by volume of solution into 100. Let us now have a look on activity. Suspension. Suspension is a heterogeneous mixture where solute particles do not dissolve in solution and remain suspended in bulk medium. Let's discuss some properties of suspension. Suspension is heterogeneous mixture where particles of suspension can be seen with naked eye. Particles of suspension scatters beam of light, making path of light visible. Particles of solute settles down when suspension is kept undisturbed, and hence they can be easily separated by process of filtration. When particles settle down, suspension breaks, which also stops the scattering of light. Here we complete the learning of suspension. Thanks for watching this video. Separating the components of a mixture. Dear students, a mixture may contain various useful components. Hence, to extract these components, various methods of separation are used. Generally, For heterogeneous mixtures, components are separated by hand picking, sieving, filtration methods, etc. In this video, we are going to learn some special techniques for separation of components from mixtures. Evaporation. This method is generally used to separate non-volatile component from volatile component, where volatile component easily evaporates, leaving behind non-volatile component in mixture. For example, ink is made of dye and water. Dye being non-volatile gets separated from water during process of evaporation. Let us now have a look on activity. Centrifugation. Sometimes in solid-liquid mixtures, solid particles are so small that they easily pass through filter paper, thereby makes their separation impossible. In such cases, technique of centrifugation is used. In this method, a solid-liquid mixture is allowed to spin in container. During the spin, force acts in inward direction, due to which heavy particle settles at bottom while lighter particles remain at top. Applications of centrifugation. Let us now have a look on activity. Separation using separating funnel. This technique is mainly used in case of mixture of immiscible liquids. This mixture is poured in separating funnel and is allowed to stand still. Immiscible layer of liquids are visible, which can be easily separated by opening stop cork. Applications. Let us now have a look on activity. Sublimation. This technique is used to separate sublimable volatile impurity from non-sublimable volatile impurities by process of sublimation. Chromatography. In this method, spot of sample mixture is applied on filter paper and then filter paper is placed in solvent. Components in mixture which are more soluble in solvent rises faster on filter paper, thereby separating all components from sample. Application. Let us now have a look on activity. Distillation. This process is used to separate two miscible liquids having sufficient difference in boiling point. In mixture, liquid with lower boiling points evaporates first, undergoes condensation and is collected in container. Liquid with high boiling point evaporates later, hence it becomes easy to separate both liquids. Let us now have a look on activity. Fractional distillation. This method is used to separate miscible liquids having less than 25 Kelvin temperature difference in their boiling point. Apparatus is similar to simple distillation. Only fractional column is added in between distillation flask and condenser. Due to low difference in boiling point, both liquids evaporate simultaneously and face obstructions in fractional column. Due to obstructions, liquids with high boiling point condenses down in the flask and liquid with low boiling point reaches the condenser and is then collected in container. Hence liquid gets separated. Here we complete learning separation of component of mixture. Hope you enjoyed learning.
Evaporation, the process of change of a substance from liquid state to vapor state, is known as evaporation. It is a process which takes place at any temperature from the surface of a liquid. So, it is considered as a surface phenomenon. The molecules of a liquid are in a state of constant motion. The molecules at the surface acquire sufficient kinetic energy from collisions. They overcome the attractive forces of other molecules and escape to the atmosphere. This process continues and results in evaporation of the liquid. Evaporation causes cooling. If a drop of ether is placed on the palm, it disappears within a few seconds and the palm feels cold. This is because all molecules in a liquid do not have the same energy. Though most of the molecules have an average kinetic energy, some molecules may have higher energies. These high-energy molecules are able to break away from the cohesive forces and escape as vapors. The average kinetic energy of the remaining molecules therefore falls. The remaining molecules draw the necessary heat from its surroundings to increase their kinetic energy and evaporates. As a result, surroundings get cooled. Evaporation in daily life. During summer, perspiration is found to cool the body as moisture evaporates from the skin. On a hot sunny day, we sprinkle water on the roof or open ground. The latent heat of vaporization helps to cool the hot surface rapidly. Earthen pot has small number of pores in it. Water seeps out through them and evaporates from the surface of the pot, thereby cooling the whole system. As a result, water in the pot becomes cool. Factors affecting the rate of evaporation. Temperature of the liquid. If the temperature of the liquid increases, the molecules moving with greater kinetic energy reach near the free surface of the liquid and may escape from the liquid surface. The rate of evaporation thus increases with increase in temperature. Area of exposed surface. The larger the free surface of the liquid, the higher is the number of molecules escaping per second. Hence, greater would be the rate of evaporation. Nature of liquid. Force of attraction between the molecules is different in different liquids. Therefore, the rate of evaporation is also different for different liquids. Force of attraction is weaker in petrol, so it evaporates rapidly. That is why petrol is said to be volatile. Nature of the surrounding. Percentage of humidity in the atmosphere. Increase of humidity in air decreases the rate of evaporation. Speed of wind. Increase in the speed of wind increases the rate of evaporation. The reason is that air blown above the surface of liquid takes away the escaping molecules and space is made available for other molecules. Open space available. The rate of evaporation is more in an open space than in an enclosed space. In an enclosed space, the molecules escaping out of liquid surface are trapped. Since the molecules are in random motion, some of the trapped molecules may return back to the liquid. But in an open space, the escaping molecules do not return back to the liquid.